let's talk about writing a function rule. So before we start, let's talk a little bit about some other important information you need to know. Functions are equations that follow a rule or a pattern. And we've talked about the different types of functions we can see, linear, quadratic, or in our case, we're just talking about neither. They have specific names. But to be able to be a function, you have to have some inputs and outputs. So we have an x variable and a y variable when we are talking about functions or coordinate pairs. And our x's have other names they may be called by. Inputs, domains, independent, and we'll talk a little bit more about that. And then y variables can be called outputs, ranges, or dependent. So for example, if we were to graph something, and you do this quite a bit in science, and we have two different variables compared to each other, we always put the independent variable, or the x value, on the x-axis, and the dependent variable on the y-axis. So some examples of that may be this. So I have a kind of chart here, and let's say our dependent is the amount of checks. So remember, our dependent is the y values, and we are thinking what has control over the dependent of how much your check is. Well, it might be the number of hours worked. It might be the number of sales you made, or the number of children that you kept if you're getting paid by a child, maybe babysitting. The height of your grass could be dependent upon the time since you mowed it last, or the amount of rainfall that we've had. Okay, could be the type of grass that you have. So the height of the grass is dependent upon these other things. So the time and the rainfall we don't have control over. That is what causes the grass to grow. We think about speed of the car. Lots of things can impact that. So it's dependent upon maybe the type of car. Maybe it's a sports car. How much pressure we put on the gas pedal. Maybe it's maybe you have nitrogen in your car and it's like a speed. Maybe it's the level of nitrogen that you have if you're talking about like some kind of speed racers. Your grade in math. It might be dependent upon your effort. It might be dependent upon your comfort level or your completion rate, or depending on how your teacher grades participation. Okay? All right, so remember the difference between independent, those are your x's. They usually have the control over something happening. So in our case, whatever we input or whatever's the first thing that controls something else, and that's your dependent. All right, so we're going to talk about how to write a function from a table. So the first thing you have to know is that remember that f of x could be g of x, h of x, anything like that. F of x is the same thing as y. Okay, it's the output. So when we talk about functions, we have the f of x in place of the y. Now, we're going to write a rule, and we're going to write it in a certain form. And this form is not something we've talked about before, so this is something new. We're going to write it in slope, intercept form. Now, slope-intercept form is one of these that you're going to get very familiar with. And it is y equals mx plus b. So let's talk about the parts of that. The y is just a y, the output or the dependent. It's the y in the coordinate pairs, and the x is the x in the coordinate pairs. The m, however, is a little initial or a little letter that they use to identify slope. And we'll talk about what slope is in a second. And the b is the y-intercept. And y-intercept means where on a graph would the line, or whatever we're graphing, hit the y-axis. So if we're talking about a little x and y coordinate plane, if we have a line going through here, right at this little dot right here, it's hitting the y-axis. That would be our y-intercept. Our slope is how steep the line is, whether it's going positive or if it's going negatively. It's how steep that line is. So, and we'll talk a lot more about slope later on. You just need to know the form right now. But to find slope, it is actually the change of y's over the change in x's. All right, and another way you might hear that is rise over run. All right, so let's talk about how we could find that. So we're going to look first at our x values. And we have this table, 1, 2, 3, 4 in our x's, and 5, 9, 13, 17 in our f of x's, or our y's. So we're going to look and we're going to say, how do we get from 1 to 2? Now, we're just talking about adding or subtracting right now when we're talking about y equals mx plus b, or slope-intercept form. There's other ones that we'll learn as we go where we look for more advanced situations where they may be multiplied to get there, or divided. But we're just looking, what did we do by adding or subtracting to get to the next number? So to get from 1 to 2, I added 1. To get from 2 to 3, I added 1. To get from 3 to 4, I added 1. Great. Same thing all the way down. Now I'm going to look at my outputs. From 5 to 9, I added 4. From 9 to 13, I added 4. And from 13 to 7, I also added 4. So we're going to find our slopes first. That is the rise, or the change in y's. So if I look at my change in y's, it was every time it changed by 4. So change in y's was 4 over the change in x's. Well, the change in x's was 1. So my slope is actually 4 over 1, or we can just say 4. Okay? So now let's look and see, can we find our x, or our y-intercept, y-intercept. So when we know, what we're going to do is we're going to say y is equal to, now we know that m is 4, and we don't know b. So when we don't know b, we're going to plug in to find b, because on our table, it's not telling us where the y-intercept is. Y-intercept would always be when something is 0. Now, we could do some algebra and figure it out, or we know that we went up by 1 each time. And if we wanted to find out what 0 was, when x is 0, what is y? What is the output? Which would be our y-intercept. Y-intercept is always when x is 0 and y is something. So we're going to put in 0. Well, how will we get from 1 to 0? Well, we would just go back 1. But it's the same thing as going from 0 to 1, up 1. Well, if we went back 1 and got to 0, we could go from 5 and go back 4 and get to what that output's going to be. So from 5 to the one before, if I put it in, I know that if I take 4 away from 5, I get 1. So I know that my b, or my y-intercept, is 1. So now I rewrite it as y equals 4x plus 1. This would be my answer. All right, so let's go a little further. So here's another table. First, we're going to look at how do these change. So we're going to look, how do we go each time to get to the next one. So -2 to -1, I added 1. -1 to 0, I added 1. 1, 2, or 0 to 1, added 1. 1 to 2, added 1. Every time, I'm adding 1. Now, let's look here. From -5 to -4, I added 1. 4 to 3, added 1. 3 to 2, added 1. And you can see this pattern is continuing. Now, these are pretty straightforward. So now I know my change of y's. So rise over run. My change in y's were 1. And my change in x's was 1. So 1 divided by 1 is 1. So my slope is 1, which we call m. So we'll start with our equation, y equals mx plus b. We now know what the m is. This is going to go where m is. Now, if we don't know what the b is, nobody's telling us, we need to look at our table first. And we need to look where x is the 0. So we're looking at coordinate pair, where x is 0, and we want to know what this number is here. That's going to tell us where it hits the y-intercept. So if we go over and look, oh, look, I see that x is 0 right here, and when it's 0, its output is -3. So that is my y-intercept. So that's -3. So we can rewrite this as y equals m, we know is 1, x minus 3. Now, we don't have to write the 1 in front. We could just leave it as y equals x minus 3. That's the same thing. It's understood there's a 1 in front of that front of that x. So either one of these would be acceptable. Now, I'm writing them as y, but they're function rules. We need to write them as f of x equals x minus 3. This is written as a function rule. And if we wanted to check to see if we were right, we could take any number here and plug it back in, our input for x, and see if we get our output. So for example, let's look at our table. I'm just going to pick an easy one, like the 1 and negative 2. So if I plug in 1 for x, 1 minus 3, do I get a negative 2? Yes. So I know that my rule is right. You could try another one. If I plug in 3 minus 3, do I get the 0 here? Yes, I do. So I know that my rule is correct. All right, I want you to try this one. Pause the video and see if you can do it. All right, so you see, you found your changes in y's, which was 4, over your changes in x's, which was 2, and that simplifies down to 2, so your slope is 2. Put it into your slope-intercept form, y equals 2x plus b. Then look at your table. Do you know what your y-intercept is? You look, and when you see 0 is the x, what is the output? It's 3. So then I wrote it as 3, and then write it as a function rule. F of x is 2x plus 3. You can always check to make sure. So let me just try one. Let's say we try 2 and 7. So when I put in f of 2 into my problem, I should get out the answer 7. So 2 times 2 is 4 plus 3, and that does equal 7. And that is correct right here. Very good. All right, let's try another one. This is a 1 star, so I want you to try it and then come back and see how you did. All right, so on this one, when you first start, you may notice that it's not consistent all the way down. I have a 3, then a 6, and a 3, and then a 9, an 18, and a 9. So remember, I'm looking at the change of y's over the change of x's. So if we look at this first pair here, so we have this pair here. From 1 to 4, we went 3. From 5 to 14, we went 9. So 9 over 3 simplifies down to 3. So that tells us the slope is 3. But let's look at these other ones. What if we look at 4 going to 10 and 14 going to 32? We notice that the change from 4 to 10 is 6 and 14 to 32 is 18. Well, let's look. 18 over the change of 6, that still simplifies down to 3. So the slope is 3. Don't get thrown off by something not being consistent. You have to check. Is it the same thing? They just left out some extra stuff in there and skipped some values, and that happens quite a bit. So we know our slope is 3. So now let's look at how we're going to put that in. So y equals 3x plus b. I do not see on my table where x is 0. It's not there. I could put it there and try to figure out what it is, but the problem is going to be I went by 3. 3 is not going to get me right back to 0. So I'm not going to get an easy number. So I'm going to have to think a little bit more. So the way we do that is we can pick any coordinate pair, and I'm going to pick the easiest one. So I'm going to pick 1 and 5, and I'm going to plug them in to my equation, right where the y and x are, okay? And then I'm going to solve for b. So this is what this looks like. Y is 5 equals 3 times x is 1 plus b. I'm trying to find b. So 3 times 1 is 3 equals 5 plus b, and I'm just solving for b. So minus 3, I get 2 is equal to b. So now I know what b is. So now I can put it into my formula. Y equals m, we found out already is 3, x, and now we know that b is 2, so plus 2, and this would be our rule. So we write it as a rule, and now we're going to check it to make sure it's a rule. We are pretty sure, but let's double check. So we're going to pick another thing, maybe 10, okay? So I'm saying when I plug in 10 to this rule, I should get out 32. Oops. 32. All right, so 3 times 10 is 30, plus 2 gives me 32. So it does work. So I know this is a good function rule.